Who is SRE here? DevOps? Anybody? Platform engineering? Any names? Yeah? Okay, nice. I'm Ivan. I'm SRE at PerfectScale. And today we are going to talk about Karpenter and some of the issues we had using Karpenter. And what is Karpenter and how does it compare to other cluster autoscalers you may use now or have been using in the past? Yeah, okay, so cluster autoscaling in a nutshell. On the left, you have a cluster state. Let's say you have a deployment. It has different pod anti-affinity, all that set up, so you want to run on the separate nodes. And you have, for some reason, a cluster, not a cluster, workload scaling event. It can be new workload deployed. You can have HPA running. You can have some cron jobs, cat autoscaling, or you may have a max search for rollout, so you always add a couple more replicas of workload when you're running. And in a nutshell, what cluster autoscaling does, it launches a new node for your pods. And this is really good in terms of cloud because you pay only for instances you use, well, with some exceptions, but generally it is the case. And it's also good for on-demand because you will have more hardware space left for some other workloads. Yeah, so where it all started for Kubernetes, anybody has been using autoscaling group scaling event based on CPU utilization? Yeah, it's been, yeah. No, I was not using, but we've been using cluster autoscaler for a long time. But as some of you know, you could have actually configured autoscaling group trigger event in AWS. I'm sure there are some of that for Azure and for GCP. And based on this node resource consumption, it would scale autoscaling group, so it would add more instances, more desired state to that. Then cluster autoscaler, they started developing it in 2017. I've been using cluster autoscaler from the very beginning. And after that time, other autoscalers started to pop up. They've been providing different ways to scale up the cluster, to add spot instances if you didn't want to dangle with autoscaling group yourself. And there has been a lot of different improvements for autoscaling groups and cluster autoscalers. So you could have mixed instances profile for autoscaling group if you were like really into it. And now in 2022, AWS was like, hey, hold on, let's do something better. And they started developing Karpenter, which is cluster autoscaler. So again, like, what does it do? You have some pods which cannot be scheduled in existing cluster due to some limitations. This will track if, we will talk about node pool and node pool weight a bit later. It will track if, like, which of the node pool it should scale up. Then it will launch a node. It will mark all the pod that they should be scheduled on the specific node. And once the instance is up, it will pull all the images and start pods for you. Oh, no? Yes, please? Okay, nice. Okay, so who is using Karpenter here? Okay, yeah, it's quite a few people. I want to point out here very nice benefits we've been seeing using Karpenter. First and foremost is a nice to build platform, because with autoscaling group and with cluster autoscaler, you would need to create autoscaling groups through Terraform or ClickOps or whatever you prefer. You would need to configure cluster autoscaler, how to operate with this ASG, and this feedback loop working with developers who wants to use a specific instance type for some reason was really long. And this is nice because everything you manage inside the Kubernetes, you have all observability in one place, so you don't need to go to autoscaling group and see, oh, why it didn't scale up, why it didn't scale down, what was happening. It's a bit more smart about sizing nodes for a pack of pods, so it will actually choose more appropriate instance types for cluster autoscaling. You can provide very nice, like, you don't need to provide a specific instance type. You can specify a family, or you can specify some restrictions. So for example, launch me instances in this node pool only up until some number of CPU available. It also considers price for launching nodes. So this is great if you're into cost optimization. And this also has two very nice features, which is drift AMI detection and disruption. Disruption we will talk in a bit. And for drift AMI detection, in case you have very strict security consideration for your organization, you want to be able to say, hey, I have a new AMI available that include all of the patches, and a Karpenter will see, oh, I have a new AMI available if you specify it, and we will cover some of node pool examples in a bit, and it will launch this new nodes, and it will help you to have a very good security posture, at least on the node level. So on the right, I'm not sure if you can see from the back row, but this is like some examples of requirements, and this is restrictions you can provide for node pool, what type of instances it can launch, not type, but only zones and all that. And it's not the whole list, but it gives like a really nice fine-grained control over what's going on. Okay, so Karpenter disruption, or it used to be named consolidation. I think consolidation is a much nicer name. What it does, imagine you have two instances, instance A, instance B, and let's say it has enough allocatable space for launching 5 pods on the top and 3 pods on the bottom. Let's ignore all the daemon set. Let's not get into the details. And Karpenter can see, if you use this feature, it can spot, oh, my instances are underutilized. So I can launch a new bigger one, move all the pods from the 2 previous to a new one, and I will save either a space, so I will have less non-utilized space, or it can save you money. And it's really nice with some details. So we will cover problems with these features we had at Perfect Scale later. Okay, so what is Karpenter? We know that this is cluster autoscaler. In terms of Kubernetes terminology, it's an operator. So what it operates on? It operates on 3 CRDs, which is node class, node pool, and node claim. Node claim is more of a virtual thing. CRD you don't really control. So this is what Karpenter operator use to store the state or where it needs to progress in terms of specific instance. We don't have much control over it, but it provides very good observability. And node class and node pool, you can think of node class as a storage class. So this is like a class that's kind of reflective of what we need a cloud provider to do. A node pool, this is like actual kind of instantiation of a specific node class with some limitation in terms of Kubernetes, and we will cover this. In a minute. Okay, so a node class, and this is just an example, and it highlights a couple of things that we think important also to set up. So AMI family, you can use Ubuntu, Amazon Linux, whatever, you name it. We had very funny issues with, okay, not funny, but we had an issue with that. You want to either specify an AMI family, which can bring you kind of random, well, not random, but verified AMIs in your cluster, or you can specify specific AMIs if you like it. If you bake your own AMIs, anybody is baking own AMIs? Yeah, okay, some, yeah. Then you can specify this AMI here. Block device mapping, for example, you want to have a root device encrypted. You usually want to bump a bit volume size for a root device, not have a default, I think it's like 20G, maybe not enough for pulling all fat images and store all the logs. And we also love using GP3, so we override the default option of GP2. And some details is like a role, and security group subnet selectors. Also here we use wildcard selectors. That way we don't have to, we can have more easy deployments of the same Helm chart across all our provisioned regions and clusters. So this is really nice. But the the top part is important, and I'll have a QR code with some more sophisticated examples of node class that we use. Okay, so node pool. Again, this is working in conjunction with node class. A node class represents like a specific class. And here we can specify a configuration of disruption and different in-cluster details. And I'll go over this because I think it's important to know some of the options and to use them. So first and foremost, let's ignore disruption for a minute. You want to specify limits, so you don't over-provision too much nodes in case you have a rogue replica set for deployment and just scaling up cluster infinitely. You don't want to have that. You want to specify and limit the blast radius. We always specify how much we reserve resources for kubelet and system because, well, I'm not sure if you did it. We had this when some pod use a lot of memory and use a lot of CPU, and then you cannot even SSH into instance because it's getting throttled so heavily. Here we are referencing node class, and this is through node class ref. We of course specify requirements, which in this specific example is a concrete instance type. But you're free to use a family or provide some other restrictions. And the last one is a weight, and this is what allows us to say to Karpenter, please prefer to launch this node. And this is a very interesting setting because, for example, you have reserved instances in your cluster. Who has reserved instances? Yeah? Saving plans? Okay, also saving plans. Yeah, so you can say that, please, Karpenter, prefer to launch a reserved instance for us because we want to utilize first what we pay for and only after spin up some on demand. And this is also cool if you, for example, if you have a node pool for spot and on demand, you can control prefer to launch spot if specific instance type for spot is not available, spin up an on demand instance for me. And this is really nice. And the top section is more of is super cool. I love disruption. So budget I'll cover in a bit. So consolidation, what it does, you have two options. You have one empty and you have one underutilized. So when empty, only when the node is empty, only after that Karpenter will consider shrinking it all together. When underutilized, you can set up when it's underutilized. So for example, if your memory underutilized, under 60%. Cluster autoscaler has the same thing. Then it will start thinking how to improve a situation in the cluster. And you have expire after if you're having to dynamically fixing security issues with your nodes together with AMI family. You can have a thing where you have a TTL. The node will be running for, let's say, a week, and after this week, it will be expired. So Karpenter will mark this node as being drained. It will launch a new node, which will have a new AMI, and it will migrate all the pod from a previous node to this new node. And this is great to have this dynamically, automatically updated system, and then you just go into control plane, update control plane, and you're golden. This is really nice. Used to spend a lot of time doing cluster upgrades, so it definitely helps. And then you have a budget, so think of this as a max unavailable in terms of deployment. So you say, hey, this amount of this percentage of nodes can be, you can disrupt them, and you're free to go. And this works together with pod disruption budget. So you want to balance it out together with that. Okay, we have QR code with more specific examples and using reserved instances. This specific article has outdated CRDs. Karpenter is a very active project, so you have always some changes, and they change its CRD, but it has a good enough detail, and feel free to copy and paste and test it out yourself. Okay, so now Something we run Karpenter for 1.5 year now, and we accumulated some operational experience. So Karpenter does come with nice metrics, but it doesn't come with, oh, here's what to look for, or this alerts you should set up. So we came up with 3 main things. Node pool limits. If you specify node pool limits and your node pool is reaching the limit, Karpenter will not be able to launch new EC2 instances. So we have an alert on top of that, and that means we are almost there. We go and increase it or see what's taking the space. Second one is cloud provider errors. If you have some, I don't know, rolled out weird policy change for Karpenter role, or something's off on the cloud provider side, we also have an alert for that. And the last one is a node not registered in cluster. And I'll tell a story about that. We used I think it was Ubuntu AMI, and they rolled out a change where they do not properly escape string, and we specify our own parameters for kubelet, and the node just couldn't register in the cluster. It was a new AMI version released, so we didn't have a disruption. We have alert popped in almost immediately, but that was a scary thing in case you use this automatic AMI. So if you want to be on the safe side, maybe provide a specific AMI, or we use Amazon Linux, which we find to be more stable for us. Now, what do we monitor? We monitor pod and nodes, and I'll have a demo after that, so it's a bit more words, and then we'll check something. We monitor idle space for nodes and just see, what's going on, maybe you can improve something. We check total memory and total CPU just to have a grasp of what's going on inside the cluster. And we use spot instances. Who has spot instances? Okay, yeah, so we use spot instances. It's very good. I love it. But we want to track how much percentage. We always aim for more. Okay, so demo, and this is a QR code. We also have a dashboard. I'll show you a dashboard now released for Grafana. Feel free to go there. It's for a new version of Karpenter, and it also has this alerts example that I described. So feel free to go there, download, and yeah, it's nice. So this is how it looks like. We have one of our dev cluster. We have here, we can check for different nodes. We have 74% of spot nodes, which is good. How much pods we run. We can see cluster memory, all that here. And for example, distribution of the nodes, and we can see it's quite nicely. If you have heavier on one of the zones, you may have some resiliency issues. Just depends on your requirements. And I love this one. So it gives a specific node name. Like for me, this would be very hard to build unless you build your own exporter on top of nodes in a Kubernetes cluster. So this is a Karpenter metric, and we are able to see how much nodes we have on a specific, how much pods we have on a specific node, what is the CPU utilization, memory utilization, and all that. And this is really nice. Just open here, and you can see what's going on. What else do we have here? Oh, error codes, not claimed, not found. I don't know, probably I'll have to go and check what's going on here. So this is for observability. Okay, nice. Okay, now it's a couple stories we had and what we learned from it. We use a separate ECAS static node pool. When you provision ECAS, you can have it. I do not work closely with Azure, so Karpenter also has a provider for Azure now. If you do use, please write to me. I'll be very curious to hear your take on that. We bootstrap our system critical components that provide cluster autoscaling, attaching volumes, etc., on a separate node pool of ECAS that is not controlled by Karpenter. if you have Karpenter running on the node of Karpenter and it can kill himself, which is not cool. So use taint toleration and affinity to run this on the specific node. If you bootstrap a cluster through Argo CD or something, we also prefer to run on this static node pool initially. Okay, so careful with disruptions. Disruption, so you can configure how often or how fast they run for specific nodes. But let's say you specified 5 minutes and you have very dynamic cluster that has new pods coming into the cluster. And Karpenter will always be your friend, but it will be your friend in a very specific way, where it will just do what you says him to do, and it will consolidate. And when it consolidates, it gracefully shut down the pods. So some of the pods take longer time to start up. For example, Prometheus write-ahead log reading on the bootstrap, and this can affect your SLA for specific components in the cluster. So if you consider migrating to Karpenter, or you already have some workloads, be careful. We use one empty consolidation. We are happy with what we have. We don't need any further thing. So I suggest if you just migrated from a cluster autoscaler or setting up a Karpenter, disable it or set one empty and move towards your underutilized goal very slowly. So for example, you can mark specific pods as do not disrupt, and Karpenter will do not disrupt and nodes where this pods runs. So this is one of the instruments that you have. And only after you do that, you're like, this pods can actually be disrupted. Maybe we launch them on this specific node pool. And for this specific node pool, we do have disruption consolidation configured. Oh, this is a Slack. Okay, thanks. Okay, and so we had this issue with TTL for the nodes. Now it's way more configurable, so specify your disruption budget. But we had this issue when it would bring up a new node pool. And for this node pool, we would have a TTL. And we didn't have PDB set up for specific deployments. Then a Karpenter would just bring down and move all the pods for all the nodes at the same time, because the TTL is like 3 hours from a launch. It was launched 3 hours ago. Let me go and move them all. So be careful with that. Okay. I don't know what. Oh, yeah, nice. Okay. Also suggest you to add interruption queue. It has a little more tedious setup than just running Karpenter. So you will need to add SQS and configure all the permissions to read from that. I just suggest you do it right off when you start using Karpenter. Anybody use Spot interruption handler within your Spot instances? Yeah. So Spot instances, they have interruption signal. 2 minutes before Spot will be interrupted, it will receive a signal, and also AWS can send this to SQS. Then what Karpenter will do from here, and I'll cover some of events that can lead that can go into interruption queue. How Karpenter handles it is like, okay, the Spot instance will be terminated. What are the pods? I need to launch a specific, like the same node on the side, and then it moves pods to the new the new node. I think it's great because if you use a Spot termination handler daemon set, then it will just gracefully shut down pods and drain. It would just drain, and then it would take a longer time to move the pods to new node. And it's not only about Spot interruption, but you can, for example, if AWS cannot do a health check for instances launched, then they will also be interrupted. You can also have terminating events or stopping events. If you go into console and terminate instance, Karpenter will like, oh, I need to launch a new one, so it will help to reduce launch time for pods. Okay, node pools. I think I've covered all of the options, but again, restrict max memory, max CPU for node pools, so none of the node pools go rogue. Choose specific instance type. We actually had a lot of discussion with team on this topic, and it's not too small, not too big. Let's say if you have Micros instance available in your cluster, just keep in mind that when it starts up, you will need to put all your daemon set into that. For example, I know what you use, Fluent, Beat, we use vipccni, so vipccni, and all of the daemon set pods, and they will live there rent-free. So you will actually have way less allocatable space on this smaller type of nodes, but also not too big in case you have 3 AZs and you allow like massive instances, instance type. All your pods will be running on this, let's say, 3 nodes across AZs, and then what happens if this node gets terminated for some reason? Not cool. All the pods will be moved, so you will have a longer time, like you will have harder time to recover. Also, choose family types. We prefer not to use burstable for our in-cluster components because it's a bit unpredictable. And it's like choose family types. You know your workloads better. Also, for not too small, not too big, if it's a smaller instances, they usually have less network bandwidth. If you have network-heavy application, probably want to go bigger. Always reserve space for system and kubelet. It's not funny when you have some problem on a specific node and you cannot even just go in and check what's going on actively. Choose big enough root volume. We had some issues when the root volume was overfilled with images and just increased it, so just go big for that. If you have, well, it's more a specific recommendation for use case, but let's say you have a cluster where you have replicas that needs to replicate a lot of data among them. Maybe you don't wanna to have inter-zone traffic for that reason, and because you pay for inter-zone traffic. So you can wait node pools. You can say, please prefer to launch the node pools in this AZ, and this will laterally collocate. It will increase probability of collocation of the pods in this specific zone, so you'll pay less for traffic. But maybe some of you have that. Okay, for cloud provider, Karpenter is good, but at last, for us, you just launch instances. So interruption queue, important, and all AWS accounts, they have limits for what types and how many instances of a type you can launch at the account. So go in your console and check if maybe you have these limits, and so you know these limits ahead of time. And the last one is a bit small but important. If you have a Cedar Ranch block, if you're using AWS CNI and you have a small Cedar block for your VPC, make sure to monitor this IP addresses so you don't run in the, because Karpenter launch instances, and sometimes it launch a lot of that. So a lot of daemon set, they will have their own CNI attached to the instance, and you don't want to be in the situation where you're not able to launch pod on the node just because you're out of IP addresses, and you have sparse allocation of this IP addresses, usually in cloud providers. Okay, so I think we covered a lot of Karpenter, and what we run on Karpenter are workloads. So how to make them run better with Karpenter is, of course, first provide PDB. If you have some If you have workloads, they should handle graceful shutdown nicely. If you know that it will take longer, make sure you add it. You always want to specify resources for workloads running. That way, scheduler will be able to provide these resources for workloads and do not collocate them all with burstable type on the or best effort type on the specific nodes. And you want to optimize these resources, and after you optimized it and you run it for a little bit and you have a new version release, maybe you want to optimize it again. You always want to have just the right side, we call it internally. If you over provision request, you will have a waste of money. If you under provision, for example, a memory request, you run into the issue with higher chance of OM. If you do not define them, that works badly with cluster autoscaler. So it can lead to a lot of various problems with that. And you also want to specify limits for memory. We don't specify limits for CPU to not have CPU throttling, but you can also disable CFS for specific nodes and still specify limits, just will not play for you. And that's what we do at Perfect Scale for Workload, and it works very nicely for Karpenter. So feel free to first go to our blog post. We have more on Karpenter, and we have a couple on specific workloads. We have 30 days free trial, and if you have any questions, feel free to pop by our booth. We are on the lower floor and talk about Karpenter or workload or resource optimization that you do in the cluster. So thank you for your attention, and yeah, maybe you have any questions to me. Yes, sure. 1 second. Oh, okay.
So does Karpenter work with other cloud providers, Azure or Google Cloud?
It has provider for AWS, which is good, and for Azure they just released it I think a couple months ago. I didn't have a chance to use it. For GCP, it's not available now, but this is a very active project, and I'm sure they will release it sooner or later. Thanks.
Is an open community, or it comes from
It's
Amazon?
Community. It's in a SIG Kubernetes Karpenter project. It's open source. It's backed by, I think, a couple engineers working on this project, at least who started coming from AWS, but it's very community driven. Thanks.
Thank you. And thank you for the explanation.
Yeah.
Anyone else?
Hey, thanks.